There are other kinds of variable types apart from the int, bool, and char that we have access to. Another couple of variable types that we have are float and double. And float and double are both decimal numbers. So I can have a number like pi, 3.141592654. And I can now do math with these. I can calculate the area of a circle or its circumference. I can even print this out. Cout pi and L. Cout pi underscore D. And they look the same here. But they're a little bit different. Float and double both store numbers with decimal points, but double actually stores higher precision numbers. That means that the double value can get more detail, and it can also store larger numbers. How much larger can you store with a double? That's really not that important right now. In fact, you can probably just use either float or double, and you won't notice that much difference until you start really doing a lot of very intense math. But whenever you're doing math, it does make a little bit more sense to use floats than it does for integers, because if you make an int like this will actually result in 0. Cout number. Because an integer can't store a decimal value, this is 1/10. It's equivalent of 0.1. But an integer will just get rid of everything beyond that point. If I did 33 divided by 10, this would be 3.3, but the integer would get rid of this 0.3 and it would just give me 3. Like so. 3. But if I did this as a float, why is it only giving me 3? Oh, because I'm doing integer division. I have to actually tell it to be a float. I can, like this. And now it gives me 3.3. If I do this with a double, it will work the same. If I do logic like this, when it starts evaluating this, first it will take this right here. I believe it'll work like this. 3 divided by 10 is 3.3 times 1 is 3.3 divided by 5 is some fractional value. So I believe this will give us some fractional value. Yep, 0.66. But if I take this 1/5 and I move it here, 1 divided by 5, this is doing integer division, and this will give us 0. 0 times 33 is 0. 0 divided by 10 is 0. And there we get 0. So the order of math when you're dealing with floats and integers actually matters a lot. And don't forget about it. If you want everything to be floats, then make the first number a float, and it will all take care of itself. So far we know about ints, bools, chars, floats, doubles, but there are a couple additional types. There's a long, a short, and a long. And these are very related to an int. An int, a bool, a char, a long, a short, and a long, these are all what we call integral types, which means that they can only store values without decimal points. The integer is usually 32 bits, which is the same that a long is always. A long is always 32 bits. And the number of bits determines how large a number it can store. An integer can store from -2 to the 31st power all the way to 2 to the 31st power minus 1. That's a big number. How big is that number? 2. Oh, there's no exponent here, so I need to view standard. No, I need to view scientific. 2 x to the y 31. What is that? 2 billion. So an integer can store from negative 2,147,483,648 to positive 2,147,483,647. That is the range of an integer. Usually, that is the range of a long always. A short can store 16 bits, which means it can store from negative 2 to the 16th to 2 to the 15th to 2 to the 15th minus 1. And this is negative 32,768 to positive 32,767. A long can store 64 bits. How many numbers is that? Pretty arbitrarily large. Let's see. 2 to the 63rd equals, so it can store this negative to this minus 1 positive. That's just a lot. We don't even really worry about it. Yeah, longs are really big. Bools can only store either a 0 or a 1. Chars can store 8 bits, which is negative 2 to the 8th to 2 to the 8th minus 1. So negative 2 to the 7th. Negative 128 to positive 127. And all of this should really be commented out because my code won't compile if all of this information is written in here. I can make random numbers of these types by using a special function called ran, like this. Int random number equals rand, cout random number. And this will give me a random number. Kind of. It's actually a pseudo-random number. 41 happens to be the number that it gave me. If I put this in a loop, for int I equals 0, while I is less than 100, now it'll give me 100 random numbers. 41 every time. Actually, it's not giving me a new random number because this code right here is the code that makes the random number new. So if I do that, now it'll be a new random number each time. And look at that, all kinds of crazy digits here, starting with 18,467. If I run it again, 18,467. If I run it again, 18,467. The reason it's the same set of numbers each time, and by the way, the very first time, it actually does give us 14. If I move this to there, we'll see that 14 as the first number. Sorry, 41. I meant 41. All of these numbers are within a very large range. And I probably don't want them to be this big. They don't go all the way to the maximum integer count, but they're still pretty big. If I want to reduce the size of my random numbers, I can do this. Modulo 100. Now it'll give me a random number from 0 to 100 because it doesn't matter what you divide a number by, you're never going to get a remainder that's bigger than the divisor. So that's one really cool way that you can cap off the random number generator. It doesn't matter what number it gets, the result of this will never be more than 100. It'll get to 99. If you had any number that was evenly divisible by 100, then the remainder would be 0. If you wanted to change the random number sequence, then you would have to seed the random number generator. And you would do that with a function called srand, like this. So if I seed the random number generator to be 5, then we get a sequence that starts with 54, then goes 93, 55. So 54, 93, 55, 49. If I change it to 6, $58, $73, $19, $45. So they're 4 different numbers. If I change it back to 5, $54, $93, $55, $49. It's the same 4 numbers that we started with. So when you call the rand function, which by the way, rand is part of the stdlib.h, the standard library header. When you call rand, it's using a pseudo random number generator. It's actually using something called a linear congruential number generator, which is, it's basically a linear equation that goes through some really weird computer sciencey math things to look random, even though it's really not random. The sequence is going to be based on the seed that you give it with the srand function. There's 2 more big concepts left that I haven't covered that are used in that early program that I gave you guys, the one where you can test your Boolean knowledge. And those 2 ideas are, number 1, the ternary operator, and number 2, arrays and also pointers. This right here deserves its own lecture, so I'm going to do that soon. But I can explain what a ternary operator is without too much difficulty. Ternary, meaning 3, is different than the binary operators. For example, 1 plus 1, here the plus is a binary operator. 1 plus plus, this, actually, plus plus I, this is a unary operator because it only works on 1 element, 1 unit, and the binary operator works on 2, bi meaning 2, like bicycle. The ternary operator works on 3 things, and it will do something like this. Cout random number is equal to 0, question mark, 0, period. If I run this code, it prints 0 in front of every 0. This is like an if statement right here. This is essentially the same thing as if random number is equal to 0, cout 0, else cout, oh, how about I spell that correctly? Period. And this will work exactly the same way. This is just what we call an inlined if statement. And this is used in that little piece of code that I gave you guys earlier. Wow, that was a lot of stuff. I just went over most of the basics of logic and variables in C++. I really hope that that was educational for you guys. And if you have any questions or comments, let me know.